All right, welcome everyone to this webinar. We're going to address some preconceptions about AI-based visual inspection today. However, the theme is defect consensus, and as we know, this is about finding common ground in what a defect really is. And with the help of AI, we're going to show how this process is getting much more simple. Let's have a look at today's agenda. So, we're first going to debunk common AI myths in quality control, and then we're going to show real-world insights and practical applications. Then we're also going to show how our quality control platform Spectron provides defect consensus and simplicity. All of this before we open the floor to your questions, and we're also going to have some expert insights from our AI specialists. Now over to you, Will. Carry it away.
Thank you very much, Aline. And in true live event fashion, just as we are about to get started, my mouse just gave up and has no more battery. So I'll be doing this with my with my pad instead, which is not my mode of preference, but that's all right. As Eileen just said, this is a session where we like to address some of the preconceptions that are out there. This is our third iteration now of this kind of webinar. And in previous iterations, we've already spoken about a number of these kind of preconceptions. Like you need a lot of, you need to be an expert, you need lots and lots of data. It only works on non-reflective products and so on. But today we are aiming to have a new preconception that we're going to talk about primarily, which is that you need to have all QC parameters perfectly defined to start. This is an area, or this is a question and a misconception that we've seen time and time again, and it links to something that we call the defect consensus problem, and that's going to be the main topic for today. However, I would like to preface, before I dive a bit deeper into that, this call by saying, yes, I'm going to talk about this at some length, but please do feel free to use the chat or the Q&A function at any point to ask questions or input your own questions, right? So while this is the theme that we have chosen for today, the main idea or the main purpose of this call is also to give an open floor to your questions. So we will pay close attention to what thoughts or questions that you came to this webinar with, and we will make sure to address these as well. And as you can see, this is a very open and friendly format, so I try to keep this more conversational rather than a super structured step-by-step presentation. We do have a couple of questions that we have received in previous engagement calls, and then also ahead of the webinar, which we have set up beforehand that we're going to go through. But again, we're very much looking forward to your questions from the Q&A function as well. So this is the one for today. The preconception that you need to have all QC parameters perfectly defined to start. Why is that a problem? I realize there's quite a lot of text on this one. Maybe we should shorten that a bit. But in any case, the trouble arises essentially, especially when you are moving from manual quality control to an automated setting. And the issue is that usually it has been humans working at this, using human language to explain to each other, to potentially explain to the next chain or the next link in the supplier chain, and coming to some sorts of agreements between each other using human language and the way things have been defined, right, previously. But But that comes with a number of problems, right? So let's say you have this kind of product, which is a more difficult one to work with because it has a very non-uniform surface. This is actually from a use case that we've been working on before, which is a kind of bitumen covered and coated product. And there are some defects on here, right? But they're not easy to spot in the first place. And when they are being spotted, they are not that easy to define either, right? So if you have a look at this, can you guess where the defects are? I'll give you a moment to look closely. And yes, it's difficult. It's meant to be difficult, right? So these are the defects that we are looking at, right? But how do you define them, right? And how do you measure them? That's the question. And that gets us into exactly this kind of defect consensus problem. Because one inspector might be using their human eyes and their human tools to inspect it and come to the conclusion that I measure this at 0.4 millimeter FOD, and therefore it is a pass. While the other inspector might be using their magnifying glass, which is a slightly different brand, might be slightly different in the way it looks if they're all calibrated the same way, right? But it just feels a little bit different. And that QC worker defines this to be a fail. And you get this problem of how do you actually define it, right? And this is particularly problematic if you had these processes set up and maybe you had a bit of back and forth already between you and your customer, but now you would like to introduce, let's say, a machine vision system, right? You want to automate this process. And the supplier, someone like us, for example, who wants to implement this for you is asking you about your definitions. So how do you define the parameters that you require, right? What's the minimum and what's the maximum? That's always the question that we ask. What's the min and the max? What's the defect parameters that you're looking for? And how do you classify them? And quite often, our prospective customers then say, well, you know, we've just sort of had our guys look at it and they had their ways of defining this, and it's not perfectly set up yet, right? Actually, we may have to talk to our customer about the precise definitions, right? And then you get this problem of one saying this and the other saying that, right? And some of these questions can be quite philosophical as well. So one example that we spend quite some time with is the bubble. And the question of where does the bubble begin and where does it end, right? So if you have a look at a defect like this one, and perhaps have a look at the one on the right here, if you say that the bubble is allowed to be a diameter of, let's say 0.4 millimeters, right? Where do you start measuring, right? And if we look at it from the cross section, do you start measuring here? Do you start measuring here? Here? Where does it start, right? And that can be quite a difficult discussion, because as the supplier, you of course want to say we should start measuring only here when it's actually noticeable, right? When it is beyond what would be a normal, usual, and acceptable deviation in the surface structure. But if you are looking for perfection as the customer, you might say, no, the bubble begins at the very beginning of the bubble, right? So when you look at this picture again, you have quite the difference, right? One might define this bubble as a pass, and the other one might define it as a fail. And that gets us into this defect consensus problem. And that is bad enough when you have only two people involved in it. But if you have multiple people who are passing or who are adding components and are adding value to a given product, it gets even worse, right? Because one inspector on one end says it should look like this, the other one says it should look like this, and this is passed on to the next one who says it should like this, and it goes on and back and forth and back and forth, and it becomes more and more convoluted and more complicated, and in the end, you have everyone fighting, essentially. So this is what we have seen in live cases, and sometimes it even feels like you're waking sleeping dogs, because things had sort of worked before. Nobody was super happy about it, but nobody was also forced to actually look deeply into things and really define it and work on this kind of defect consensus. Now, machine vision has that promise to solve this kind of problem, but it requires this kind of the defect consensus work to be done before you can get started, right? And you might then ask, okay, does that mean before we can get started, do we have to do this, right? Do we have to first sit down with our customers or with everyone in the chain here and sort out these questions? And that is the kind of misconception that we want to address in this one in particular, right? Do you really have to sit down and do this? And the fact of the matter is that you probably can't even, because you don't have one unified, one standardized arbiter that is producing the same image under the same conditions with the same measurement tools for everyone to actually look at it in the same way, to define what is the right sizing, what is the right classification, and so on, right? So you have the problem that if you don't get started, or if you don't get some kind of vision system in place already, you only have these kind of tools. You only have everyone's own methods, their own inspection station, and you get this cross-talk again, where everyone is talking about slightly different visuals and slightly different items. So what our recommendation is instead is to actually get started already, right? Find, and it kind of summarized in this very first one here, right? Find some ballpark figures in the first place, which are relatively easy to define, right? Okay, we need to assess certain defects at, let's say, a range between 0.1 and 2 millimeters. That's good enough. That is good enough to spec a hardware system to it and to start capturing data. And actually, that is then the starting point, because as you capture data, you can look at these kind of defects. You can look at the measurement, or the way it presents itself in that one clearly defined, always staying the same condition system, which eliminates all of these human variables. And then once you have this image data, you can do very clear classification. Sorry, clicking through here. You can define what should be the outline, right? So this is essentially done on a pixel by pixel basis. So if you have a kind of phenotype, if you have the way a defect presents itself, you can look at different potentials, right? So what we would do, for example, on our end, is we would give you different segmentations, different outlines, how the system can detect it for you. Right? So if you have the bubble, again, we can show you in the system that this could present itself. We can make the system measure it here. And that's the outline it would look like if we make it detect starting from here. And we can also show you, but another way of segmenting is starting here, right? And then it's measuring like this. And you can define what kind of parameters you want. And then again, everyone involved in this chain can have a look at these images and come to this consensus. They can say, okay, we've now defined that bubbles should always begin here, and the system should always measure it in that way. And from then on, no more discussion, right? No more issues, no more fighting, and no more he said, she said, because that's the reality that we have seen quite a bit in these complex supply chains, where one supplier says, no, this is a defect, and sends it back. But the original supplier says, actually, no, we measured it before it left the facility, and our system or our human eyes said, no, it's not a defect. Right? So this is the misconception we wanted to address today, right? Actually, you can do, or actually, this is part of getting started with machine vision, and you don't have to do it beforehand. You can get something in place with just rough estimates or rough ballpark figures on what is required first, and then that is part of the value proposition of working with someone like us, that we can help you find these definitions and solve these kind of consensus problems with you. Right? And this, how this looks like in reality, we can see on one of our demo videos, which you can also find on our website. This is with one of our customers making these coated panels. And in fact, we had exactly this situation. So this is from a real world example where these panels are being shipped to another supplier, which is adding some electronics. Then it goes to another supplier, which is adding additional housing and is bringing it to the airplane outfitter. And then the airplane outfitter is finally putting together the whole interior for the airline. So there's multiple steps in between. Everyone was doing their own inspection, and everyone was having their own opinion on how to define these kind of defects. And what we are doing here is we are allowing the human to still input items. In this case, it's already a finished, fully running system, so that allows the operator to have some manual control as well. But you can see the function in place, or it's a similar function that we would use to arrive at this defect consensus, where the system is offering alternative segmentations, alternative ways how it could be detected. Right, so you can see in the on this button here, there's a more button. When you click that more button, you can see an alternative way this defect could be classified. And this is what we would be doing in the beginning when helping classify or reaching that consensus in the first place. And then afterwards, you still have the opportunity to have additional input, because sometimes, especially when you go to a microscopic scale, some of these defects will, in 95% of the cases, be very clear and very easily identifiable. But there's every now and then something that is presenting itself just slightly differently, and it helps to have that ability to see an additional way of identifying or segmenting this kind of defect. Right. So we had a couple. So and this is our little, of course, AI generated idea of where we arrive if we move from here to this. If you have it in place and if you have things set up properly, you can actually solve these he said, she said, and this I measure it this way and you measure it that way, troubles, and arrive at a happy, everyone is in agreement situation, right? So you have that independent arbiter, you have the definitions in place, and you have no more hassle in between. Good. That's the misconception we wanted to talk about this time. We're going to have more in future iterations, but for now, it's we would like to open the floor for questions from you guys. So in order to ask a question, you can go to the bottom of your screen, and it should have this little items here, the square, circle, and triangle, and you can use the question function to answer any question, whether that connects to what we presented today, or whether it's a completely different question connecting to computer vision, to automated quality control. That is totally up to you. And we'll give you a moment to ask away and have a look at those. And then we'll also work on some questions that we had before already.
Yes, and if you can't see that symbol, it's because Google has a new update. So it's the square with the circles. Yeah, so if you just click there, you should have...
Oh no, they changed it. They literally changed it in the last few days before we did the slide. Yes. Okay, so it's not it's not this. It's next to the chat window still, but it's the 9 dots, meeting tools, and then there's a Q&A. All right. All right. I'll give you another moment. Yeah, so this is a question that we received beforehand. How do you ensure consistent defect identification across different operators, inspectors, or AI systems? This is exactly connecting to this question of achieving defect consensus. Right? Ideally, as long as you have the possibility to do so, you take the human out of the equation, because whenever you have a human doing the inspection themselves, you run into troubles of, how many coffees did the person have that day? Did they rub their eyes too much in the morning? Right? These, especially when you go microscopic, these differences can be so small, and one day the same person might define it as 0.4. The next day they might define it as 0.5. Right. So the human variable is really quite problematic, and having this kind of independent arbiter can be really quite useful. So what we can offer, for example, is having multiple inspection systems. Right, you can have one that sits at the end of line of the first supplier. You can have an incoming inspection at the second, and another incoming at the third. And perhaps if there's a lot of process that is happening at the third supplier that can introduce additional defects, you can have an outgoing one there as well. And all of these can also speak with each other. They can talk to each other. They can cross-reference. They can track each product as it goes through, and identify trends in what kind of defects do we see happening along the supply line, along the production line, and give you insights that you can bring back to the production line or the supplier chain to reduce the amount of these kind of defects that are happening, right? And otherwise, the way to approach this is really to simply have all of the data generated uniformly for everyone to review, and then you can agree much more easily. Right? What do I mean by that? If you don't have a unified or a uniform scan of a given product that everyone can review together, and it's the same data and it's the same scan for everyone, again, it's really troublesome to have a proper conversation because you don't really know what you're talking about. So imagine the panels that I showed you just now. If that is sent from one to the next, to the next, to the next supplier, each of them looks at it with their own tools, in their own lighting conditions, after it has been transported, after it has been processed and so on. We're not really talking about the same things, right? But we're trying to reach a consensus. So if you have a system that is doing a proper full scan, everyone is looking at exactly the same data, right? It's not looking at just a few parts or square centimeters of a given item, but you can actually look at the same cases, at the same parameters, and come to a proper conclusion. Now, I saw there was another question to send in. Is that correct?
Yes. What if? There it is.
Yeah, what if we don't know what all the defects are that we may need to detect? That's a very good question, and it connects to the same thing, right? So if you have humans look at these items, they have their own ideas what to look out for, and they will only look for the defects that have already been defined, and they will also stop looking usually whenever they come across a critical defect, something that is a fail condition, right? So you might miss out on anomalies or on parameters that are indeed relevant further down the line of the supply chain, for example, because you don't have the full picture, right? So here again, having an automated system, having a system that does these scans for you can be extremely helpful because you get the full data, you get the full picture. We can also flag things that are anomalies which are not currently identified as a defect yet. But if we track the product throughout a production line or throughout a supply chain, we can predict and we can tell you that whenever we see this kind of anomaly, it has a certain probability of becoming a defect further down the line, right? So once again, this is something that is being enabled by the system, and you also still don't have to know that beforehand. You can get started with an inspection system, and we would help you find these things out. We would help you define or uncover additional parameters that would make sense to check out. This might even include having to upgrade the systems, as in previously you thought it's fully addressable with just optical sensors, but actually it turns out it might be useful to add some line scanner or something else that assesses an additional quality parameter that was not previously addressed, right? So all of this can be sorted out and can be addressed while the project is live and can be done quite quickly as well, right? And it doesn't have to be pre-agreed already. So thank you for that question. Oh, there's another one. So if I didn't have all the defect examples, what would be needed to get this type of system started and working? Usually, what we see when we talk to manufacturers who are currently doing manual QC is that they have at least some domain knowledge, or they have some idea how to do this, right? It's a human who does it currently. Ideally, they have some kind of defect catalog, which is just an Excel file or a PDF that lists the type of defects that they are looking at, with some ballpark figures, right? It might even be quite roughly defined, right? It might be something like, hold the panel at arm's length, and if you can see it with the human eyes, then it's a problem. If you can't see it, then it's not a problem, right? That is essentially enough for us to get started. These kind of instructions, these kind of descriptions of how the QC is done, and this is what is required within the supply chain, can be enough for us to spec a system in terms of resolution, in terms of what kind of sensors are required. And then once the first system is in place, we can review the data together. We can review what images are being generated and what these defects that you have previously done with humans, how they look like in this uniform machine vision environment, right? And then we look at it together and define it and make sure that this is capturing all of the parameters that are important for you. So if you're asking what is needed, I think we have it in actually one of the much earlier slides. We had a similar question last time. Right? What is needed on your end is just to tell us and teach us the same way you'd be teaching a human worker, right? The same way you don't have to show a human worker thousands of images, and you don't have to spend all of that time labeling data and whatnot. You just show one example and you sit down and explain it the same way our system or our team would listen to you, take in the methods and use that to translate it into everything that is needed for our system. And now our system happens to be uniquely positioned to do that very well and very quickly, because we can, our system can imagine the same way a human does how these defects also present themselves, and create its own synthetic data set to train itself. Right? But yeah, long-winded answer. The short version is you probably don't need anything beyond what you already have. If you're currently doing manual QC, you just have to share everything that you're doing manually with us, and that can be translated into what is required in order to teach an automated system to do the inspection for you. Does that answer the question? Well, it's not a chat, so I can't see if it does or not. But I hope it does indeed. Right. Yes, thanks. Okay, wonderful. Okay, I think I addressed most of this, right? Yeah. I think we had this as well. Yeah, so this is going a bit deeper into how you actually do it if you have different sites, in a bit more practical depth. As in, first you generate the example scans that you can then view together, and you can use that in order to define the different types of defects, which we then can bring back to the training and to the synthetic data generation, and create the control models that do the inspection for you. Right. All right.
All right, it seems that we have another question here. No? Maybe that was it, yeah?
I think so.
All right.
Wonderful. In that case, one more chance for additional questions. Otherwise, we'll close this one for today and return in a month's time with some additional topics. Speak now or forever hold your what's that phrase?
Or forever be silent.
Yes.
Yes.
Wonderful. Thank you, everyone, for your input and your questions. I hope you join us again next time, and have a lovely day for today. Thanks, everyone.
Thank you so much, everyone.
Bye for now.
Bye-bye.